Now we're going to start talking about the pH scale. So continuing our discussion of chemical reactions, specifically acids and bases. First thing to be aware of is that all aqueous or all water-based solutions are going to have some amount of hydrogen and hydroxide ions present. Now the concentrations of these are typically very, very small, and one way that we can describe their concentrations is with this pH scale. Okay? Now, the way that we find pH is using the negative logarithm of the H plus concentration or molarity. So H plus molarity we describe with these parentheses, okay, these not parentheses but these square brackets. And so this is saying concentration, the molar concentration of H plus denoted by this. So whatever that value is, you would place into an equation where you see this. pH, so my pH value is equal to the negative log, base 10 log, of the hydrogen ion concentration. The pH scale as we see it here, notice a couple things. We have our H plus concentration as 1, 10 to the negative 1, 10 to the negative 2, 10 to the negative 3. So notice that this is going to be a high H plus concentration, and all the way on the other end we have a very low H plus concentration. The greater the negative exponent, the lower the concentration is. So with this in mind, our pH values are based on the negative logarithm. So if it's 1, the negative logarithm of 1 is 0. So the lowest pH, which would be completely 100% pure hydrogen ions in solution, would be a pH of 0. 10 to the negative 1, 0.1 molarity gives you a pH of 1. 10 to the negative 2, 0.01 gives you a pH of 2. So you notice the less and less concentration you get, the higher and higher the pH value gets. So the way that we break this down is to the left of the scale, on the pH scale, the low values are acids. The far right values have a very, very low hydrogen concentration, and these are the bases. Directly in the middle, okay, right around this 7 is what we say these solutions are described as being neutral. Okay, they're neutral. They have roughly the same concentration of hydrogen and hydroxide present. So a high H plus here, this would, to think about it as well in terms of the other concentration, it has a low hydroxide. A low hydrogen concentration indicates a high amount of OH minus. And right in the middle, you have H plus equal to the OH minus concentrations. Now go ahead and pause this. I assume that you've taken your time now, and I will go on with my solutions. Solution of HBr has a very low pH. It is an acid. Acids have low pH. A sample of vinegar has a pH about 2.4. It is a, remember, if it is less than 7 means acid. So it is an acid. An ammonia cleaning solution has a pH of 12.0. So recall, if it's greater than 7, it must be a base. So this is a base. When 50 mils of a 1 molar NaOH solution reacts with 50 mils of a 1 molar HCl solution, NaCl and H2O are formed, and the final solution has a pH of 7. This saltwater solution is, again, pH equal to 7 is what we call a neutral pH.